start with domain and range. Okay, so we talked about relations. Relations is right an ordered pair, a set of ordered pairs, uh, and it could be anything. And then we checked whether or not that relation would also be a function. Okay, and so when you're just looking at points, uh, right? If you were to, we looked at just a bunch of points. If I gave you points like this, right? How could you tell if that's a function? Well, if the same x value points to different y values, it's not a function, right? Right away you could tell. And then by looking at a graph, if you do the vertical line test, if you cut that graph somewhere and it crosses it more than once, it's not a function. So here, for example, right, if I were to cut it here, I'm going to touch it here and here. So this relation is not a function, okay? Same with this circle down here, right? If this is the relation that you have, if you cut it anywhere, you would always hit, right, the same x value. So x value 1, let's say, is -2 for the y here, and there's a y value of +4 up here. That can't be. It can only have 1. Okay. And this one, for example, here is, at first, if you were to do a vertical line test here, no problem. But then it does turn into itself here, and that is a problem, right? If you were to, there should be no line, no vertical line that you can draw that would hit more than one y value. If that is the case, it's not a function, okay? So that was, in summary, what we did. And then we talked about plugging in numbers and values into functions and kind of turning from equation to function notation. And so we ended up here. So if you can look up this page right here, unfortunately, I should have added page numbers to this, but it's too late. So if you have this in front of you, you notice that there are different functions and they all have different letters. G of H, F of, sorry, G of X, F of X, H of X, J of X, and this could continue, right? And these are all doing different things to X, right? They're different operations, and so we'll figure out the answers on the back side of this, but I will do a couple. So g of x, g of 10, right? We're talking about this function here. So you're plugging in 10 for x. So g of 10 here would be -3 times 10 plus 1. That is -30 plus 1, which ends up being -29. Okay. And I need you to understand this. You have just found a point on this function, and the point is when x is equal to 10, y is equal to -29. That's what you've just found. Like when you find this -29, you're like, oh, when x is equal to 10, y is equal to -29. So it's actually a point on that graph. Later on, we're going to graph these things. Okay. Let's do a little bit of a trickier one here. F of x is tricky because of that squared. Okay. So I don't know if you notice on this side, these are easy to do. You just plug in and go. But on this side, you're working backwards, right? They're giving you what the output is, and you need to figure out what the x value would be. So I'm going to do this one here. G of x, we're talking about this function right here. They're telling us that this is 16, right? So the y value is essentially 16. So we plug that in. 16 is equal to -3x plus 1. So you got to be really good at inverse operations here. Okay? Always take care of the addition or the subtraction, and then worry about what's multiplying or dividing x. Okay? So the plus 1 comes over -1. and you end up with negative 3x. Watch for your signs, okay? And then this gives you 15 is equal to negative 3x. And here you divide by negative 3. And so x is going to be negative 5. Okay? So at the beginning, watch this, folks. At the beginning, they were saying, hey, what is x when y is equal to 16? That's basically what the question is asking. And now you said, well, it's actually negative 5. When y is 16, then x is equal to negative 5. Okay, so this is, you found that there, and that's what you get. Let's do, yeah, this B. I won't do all of them because the answers are there, okay? F of 3, so we're looking at this function right here. So f of 3, notation is important, right? 3 squared. So x squared, right? So 3 squared plus 7. Okay, and that gives you 9 plus 7, which is 16. That would be it, by the way, right there. That would all I would need you to do. But you found the point 316. Okay. And this is the one that some of you might have scratched. This is the one that some of you scratched your head on a little bit because the answer is plus and negative, and I'll tell you why that is. Find x if f of x is 23, so we're using f of x, right? So we go 23 is equal to x squared plus 7. The 7 comes over subtracting, and then you end up with 16 is equal to x squared. Okay. You need to take the square root of that. Okay. And the answer is x is plus or minus 4. And that's new to you. Okay. And whenever I will make a note, this is rare. Okay, you're gonna see more of this next year. Okay. When taking the square root, right? The answer can be plus or minus. Okay. And this is the rationale. Plus 4, if you plug in plus 4 into x squared, you get 16, right? Positive plus 7, that'd be 23, right? If you took a negative 4 and plugged it in here, what do you get? If you square a negative, you get positive 16, right? Plus 7 is still 23. So we didn't do this before, but for moving forward, that is actually the case. Both of them are possible solutions, okay? I'm just going to mention it. I'm just going to leave it there because that's going to be a thing next year, not so much this year. H of A, that's kind of a interesting one, right? Why? There's a letter there, right? H of A, so we're talking H, right? So this equation here, H of A is going to be 12 over A. Is that what the answer leaves it at? Yeah, it does. Let's do a negative. Here, J. If J of X is negative 3, so that's negative 3 is equal to J of X is 2X plus 9, right? So the 9 comes over subtracting, so that's negative 12 is equal to 2x divided by 2, x is equal to -6. So there is that. I think I'll leave the last one. That one is pretty straightforward. The answers are there. Any questions on any of these ones? Anyone in particular? I think I'm going to give this a little bit of attention here. These ones. You might have had to use loose leaf on those. But it's just working with fractions, and you got to be comfortable with that. So I'm kind of going to scan through and, for example, find answer 9. So that's f of -2/3. F of -2/3. I'm just going to go here, and you should have done this on loose leaf, right? But that's this one right here. Okay, so we go 1/5, and then you plug in your x value, which is -2/3. So you got to be very careful here with signs and everything. -4. That's I'm really just plugging in the x value in here and rewriting it. Okay, and so this gets 1 times -2 is -2, 5 times 3 is 15, and that will be -4. Okay, and what do you do here? Oh no, I don't like fractions, right? So what you do is you go 4 times 15 is 60 over 15. That's the trick, because this will get you 4, right? And so that's -62 over 15. That's what you get. And sometimes it's just weird like that, and that's, you leave it at that, okay? So no worries there. So again, the answers are all here. Okay, so you just have to be careful and make sure you get it. We try to stay away from decimals. There's a decimal answer here. We try to keep it as a fraction, so just leave it. As long as it's reduced, we're happy. Okay. Okay. Let's do what we actually wanted to accomplish today, which is domain and range. I didn't do the attendance yet, right? I'll do that. Let's just keep going. 5.5, determining the domain and range values from the graph of a function. That's the title. And we're section 5.5. I always want you to think of domain. You're thinking horizontal, and range, you're thinking vertical. Okay. Or you can think of the x values and the y values. Right? So both of them kind of go hand in hand. Okay. Here's the graph of the function f of x is equal to -3x plus 7. So we'll show you how to graph that later. I just want to highlight something. This is plus 7, right? Notice where it's going through. 2, 4, 6, 7, right? That's going to be a pattern. It's called the y-intercept. Determine the range value, the output, when the domain value or the input is 1. So when x is equal to 1, right, this is 1, what is my y value? They're asking this. When x is equal to 1, what is the y value? That's what they're asking. So you find x is equal to 1, and then you just go up until you get, I'm just going to use the red here, until you hit the line and it's right here. And then you can tell, right, you went up and then over, so it's actually 4. So it's the range is positive 4. That's a weird way of writing it, but they want you to associate range with y and x with um, the domain, okay? Here, determine the domain value, that's the x value, when the range is 1. So here they're saying, hey, find what the x value is when the range or the y value is 1. So here we're going the opposite way. You start with y is equal to 1, which is right here, and then you're going to go out until you hit the line, and so that tells you that you're going to use the 2 there, okay? So the domain is 2, okay? The domain is 2. When the range is 1, the domain is 2. You can think of it as x values and y values, right? Let's keep going. Here's the graph of the function g of x is equal to 4x minus 3. I want you to highlight something for me. Notice that this is negative 3 at the end here. Count from the center, you go 1, 2, 3, minus 3, it goes right through there. So that's a pattern that you're going to see, that constant at the end tells you where that line is going to cross the y-axis. Okay, determine the range value when the domain value is is 3. Sorry. So what's the range when the domain is 3? So 3 question mark. That's really what they're asking, right? So you go over here and find x is equal to 3, which is right here. I'm going to use red again. I'm going to start here at 3, and I'm going to go until I hit the line. Boom. And then just move over until you hit the y-axis. So this is 9 here. Okay. So it's the range is 9. Okay. So we can go from x to the y or from y to the x. Okay. Determine the domain, right, when the range is negative 7. So they're saying, hey, find the x value when the y value is negative 7. Negative 7 is right here, right? Because it's 5, 6, 7. And you just move over, and then that will lead you to the x value that is associated with this point, which is negative 1. Okay. I'm going to add something here. Maybe not. No, I'll just leave it at that. So this is one way of doing this, of finding the domain for the range, like the pair that go together. We'll find another way right here. Example 3, consider the graph of f of x. Find f of negative 1. So we're doing the same as before, but we're not using the domain and range wording. So when x is equal to negative 1, what is the y value? That's what they're asking, because you always have to remember whatever is inside there represents the x value. Okay, so we're going to go, where is x is equal to negative 1? It's right here. This is the negative 1, so we just go up. And this is 2, right? So f of negative 1 is going to be positive 2. F of 4, when x is equal to 4, what is the y value? So f of 4 is going to be, we're going to find x is equal to 4. So 1, 2, 3, 4 positive. This is 4. And the line is up there, right? So we're going to go hit that point and then move over here. And then we're going to count 2, 4, 5. This is 5. Just counting the boxes up, positive 5. So in this case, it's 5. F of negative 3, again, think of it this way. If x is equal to negative 3, what is the y value that goes with it? You start at the origin, 1, 2, 3 to the left. This is negative 3x. So we go up, and it happens to be 5 as well. Okay, that is fine. This is okay. It's a function because it's two different x values that point to the same y value. That is okay, but the other way is not. If you had an f equal to 4 and it's a different here, then it's not a function, right? So this is definitely a function. For what values of x does f of x equal to 2? So let's put it this way. What are the x values when this is equal to 2? And notice this. I will draw a line using a highlighter where y is equal to 2. And this is the line. It's a horizontal line, right? And how many times when y is equal to 2, it happens there's 1 here, 1 here, and 1 here. So there are 3 x values for this y value. Okay? There are 3 x values with a y value of 2. So x is equal to negative 4, comma, right? That's one option. It could be negative 1, and it could be positive 3. Okay, so this is in this case, and that is fine. For a function to have many x values pointing to the same y value, that is okay. It doesn't violate the vertical line test, right? Okay. I'm going to ask you to try to answer these questions here by just looking at the graph. Okay, and I'll do the attendance. All right. Determine g of negative 3. You look at that, right, and you're not used to this notation, but you just got to remember, right, that value is really x, right? So they're asking if x is equal, this is to help you think. If x is equal to negative 3, what is the y value? That's really what they're asking. So g of negative 3, negative 3 is right here. It's 0, okay? It's 0. G of 3, I'm going to stop doing this because otherwise you're going to keep adding that to the work. You don't really need to add that to your work. G of 3 is 1, 2, 3. X is equal to 3. Y would be negative 3. Okay, so it's basically you start here, and then move over. That's negative 3. Okay, determine the x value, the value of x when g of x is equal to 3. Right, so here you're thinking, what's x value when y is equal to 3? So that's your starting point, right? So you go 1, 2, 3. X is equal to 0. Okay, because x doesn't move here. X is equal to 0 there. determine the value of x when g of x is equal to 1. So when y is equal to 1, you have two directions to go to there, and it keeps going to there, right? So I don't know if you want to do a highlighter thing, right? Like basically just use that as a reference and to point out that it happens. There are 3 x values. There's one here. There could be more, by the way, folks. Like if this is an up and down wave, you have to state them all. So x could be equal sign, right? It could be, I'm going to start with the lowest here. 1, 2, 3, 4. It could be -4. It could be -2. And it could be +1. Determine the value of g of x when x is equal to 4. So x is equal to 4 here, and we're going to go down here. And this is a tricky one, right? Because it's not right at an intersection, so we're going to say -2.5. Okay. G of 4, g of x, right? That's the function, which is in here. But now we want when x is equal to 4, so this is how we write it. G of 4 is going to be -2.5 or -5/2. Okay. I know it's a little different, right? The way we talk and mention things here. I know it's weird, but we need to do this before we move into domain and range. We need to be very comfortable with notation and how to state things. Okay, translate the following statements into coordinate points. Graph the points on the grid to the right. I'm going to use a different color here to make it stand out a bit more. But this point right here is saying when x equal to -1, y is 1. So starting at the origin, we go -1, 1. Okay. This is saying that the point is when x is 2, y is 7. So starting at the origin, we go 2 to the right and then 7 up. That's 5, 6, 7 right there. I'm going to just put a little lowercase, this is lowercase a, lowercase b, 1, -1. So it'll be +1, -1. So this is C. And then we have 3, 9. So we go 1, 2, 3, and then almost all the way to the top. This is 9. I'm just going to double check. 2, 4, 6, 8, 9. There we go. That's D. And then we have 9, -3. We go almost all the way to the end, 9, and then we go -3 down here. And that's E. Just a refresher of plotting, basically. However, we're using function notation to get you to plot. We're not just giving you these coordinates here. So you have to be comfortable translating that information into an actual point. Okay, and remember, I used to, just a couple pages ago, you would calculate this value, right? You would say, hey, find f of -1, and you would calculate and come up with 1. And I told you that's actually a point, right? That you found, and boom, right? We're doing that here. Given this graph of function f of x, I wonder if I'm gonna, I think you get the point at this stage. I'm just gonna keep going. So given this graph, find f of -4. So we're just gonna do this a little faster now, right? So when x is equal to -4, what's y? So we're gonna go 1, 2, 3, 4, up to. You have to go up to get to this point. So that means that it'll be 2, right? f of 0, when x is equal to 0, what's y? Well, it's also 0. Right? So this is A, this here is B. F of 2, when x is equal to 2, we start at the origin, 1, 2 positive. You're actually going to have to go down 2 to get here. So that would be negative 2. When f is equal to negative 5, so x is equal to negative 5, you're going to go negative 5, and it also is going to be equal to 0. It's going to cross your x-axis there. By the way, this when y is equal to 0, this is called the x-intercept. It happens here as well. This will be the x-intercept. Sorry, x-intercept and y-intercept. This is just later on when you review back, it's going to make sense. Right now, you might not think of it. Okay. Find the value of x when f of x is equal to 2. So really think of this whole thing. When y is equal to 2, what is x? Right? So when y is equal to positive 2, x is equal to, happens here and there. So x is equal to negative 4, and x is equal to negative 2/3, I would say. Right? Because here, it's not quite a whole 1, negative 2/3, I would say, approximately. What's x when y is equal to 0? What's x? When y is equal to 0, right, you're not moving. You have to be careful. It's negative 5, and it is 0. There are two x values for which this statement is true. So x is equal to negative 5 and 0. Think of it this way. A function, if you do a vertical line test like this, it should never cross it more than once, right? But it could, if you do the horizontal check, like whenever I give you a y value, you got to make sure you check across, right? If this is the y value you're given, go across both ends and check if it's going to cross that graph at some point, okay? Because that is acceptable for a function. Okay. I think this one I'm going to ask you to do for homework. So just put homework here. Try the same thing again. And I can give you either post the answers or just go over it on Monday. Okay, Angie, we're going through our booklet, okay? I couldn't tell you which page number, but just keep flipping through it until we're gonna review inequalities. This is very important, folks, what we're about to do here. Okay, reviewing inequalities is important for domain and range, and I'm going to use a different color here too, maybe orange, orange highlighter or something, a marker maybe. Draw a line to represent the following inequalities. Be sure to think about whether you shade in the circle or you leave it open. Okay. So whenever, for example here, when you have x is greater than or equal to, this reads, I'm just going to say reads, x is greater or equal to 5. Okay, that's what it reads. X is greater than or equal to 5. That means that it's including, this means it's including 5. So we fill in the dot and it doesn't give you a limit on the other end, right? So you just continue with an arrowhead on the other end because it just continues. It's greater than. It's saying anything greater than. So that would be on a number line. That's how you would denote that. This would be translated to this graph on the number line. So there's no limit on one end, right? Goes to infinity. Right? This end goes to infinity. Here you have something contained, right? This is a lower limit, and this is the upper limit. Okay, so it's contained. And that means no arrows, okay? No arrowheads or anything like that. So think about it this way. This one right here, because of the equal, that means that it's included. And on this side, it's not, doesn't have the equal sign, so it's not included. Okay? Because of this, so it's going to get a little busy here. Because of that, it's not included. Not including 7. But this on this end, it says including -2. Okay? So when you have an inequality notation like this, when it's like this, when it's an equal, when you have less than or equal to, right? That means that 2 is going to be included, so it's solid. -2 is solid or filled, right? 7 is open. Okay, open. So you don't fill in that dot. This is a solid dot and this is an open dot. And notice that there's no arrowhead. So it has a start on the lower and on the upper it ends, but it would not be including the 7 in this case. Okay. And so we'll go through a bunch of examples until you kind of get the grasp of this. Okay. So here, I will keep doing a couple. So if it says x is greater than -2, right? We make some observations. -2 is not included, so it'll be open. Not contained. Therefore, we're going to have one of these arrowheads, right? So the couple of things I want you to think of when you see this. So we go to -2. Where's -2? This is 0. So we go 1, 2. You put a big circle there. Okay. And x is greater than -2. So if you're greater than -2, then your arrow will go this way. So then you just, from there, if you have a marker or something, right, we just go this way, not including the -2, right? Here it's saying, read it from left to right. X is less than or equal to 5. So 5 is included. So it's solid, not contained. Therefore, arrowhead. Okay, I'll go either way. Maybe not, because you might get confused. There's just one arrowhead. Okay. So x is less than or equal to 5. So let's find 5, which is right here. It's going to be a big solid dot like this. And we're going to go less than. So make a nice solid line on top of that number line and make sure you have an arrowhead pointing to the less than location. Okay. X is greater than or equal to 0. If this is 0 here, we know because of the equal sign that it will be a solid point like this. And which way am I going? Left or right? Greater than, less than, right? So we got to go this way. Can I give you a little, let me see here. Where would I put this? I'm going to go to the top. If it's x is greater than, right, then you go to the right, and it's going to be solid. If it's x is less than or equal to, it would go this way and it's solid. Okay? If it's just x is greater than like this without the equal sign, it would be open that way. If x is less than, it would be open, but then it would be coming to the left. By the way, I'm using x all the time. It could be y, okay? It's the same thing. So if you're looking at home or if you need to write this down to help you out, then do that. These are not contained, okay? These are all not contained. They just start somewhere and then they go either left or right, okay? So I gotta get my left and right in order here. Okay, let's keep going. X is less than 8. You find 8, so this 5, 6, 7, 8. It's open. You gotta make sure you make that obvious, okay? And it's less than, so it'd be going this way. Okay. What about here? Contained. This is contained. That means it's going to be dot, dot, like it be solid or closed, right? And both ends, both limits, not included. Okay, both limits are not included. So we're going to go to -1, the lower limit, and we're going to make an open circle. Then we're going to go to 6. I'm going to make an open circle. And then just connect those two. Okay. Give these 3 a try here, please. Take, half a minute for each. Give these 3 here a try. What would you do? Do it with pencil. You can always erase, right? Not a big deal. You're probably only going to have to erase the dot anyways. So give that a try, or at least in your mind, like I would do this, right? Just to give you a little bit of a perspective there. I'm just going to check what's on the back side of this. I'm going to go the other way, and then we're going to do domain range. Okay. All right. So this one, it's also contained. Both of them have the equal sign. So both of them are included. Both limits are included. So we go to -4, solid. We go to -1, solid, and then just connect them. Okay. Here, it's open at 3, and it's solid at 9. And you connect them. Here we are solid at -2 and open at 4, you connect. Okay, so it's -2 to 4, 3 to 9, right? -1 to 6, and so forth. So I think you get the picture. So this is going from the inequality to actually showing it on the number line. Now we're going to go backwards. All of this is to get you warmed up for domain and range. So I think I can go a little bit faster here. So we know that we're going, there's an arrow, so it's not contained. So it's just going to be x is, I know it's less than, is it going to be equal to? And the answer is no, because it's open, right? So this is 4. That's it. I will just say note here, 4 is not included. Therefore, we use not. Okay, so if you go back on your notes later, it's like, why is it that we didn't do the equal to as well? It's because it's not included. Here, and I'm using X, by the way, because all of these have X's on them, okay? If that letter had been Z or Y or whatever, you use the letter that goes with it. So now we have X is greater than, not including, and we are at -1. We put that down. Here, it's also not contained. So this would be X is less than or equal to +1. This one, I'm going up. So I know it's going to be X is greater than for sure. Since it's a solid dot, I put the equal there. And it's -9. So those are all the non-contained ones. Now we're contained. Okay, so this is different. So you put the X in the middle, do the lower first. You know that, right? X is going to be greater than this number. So we go -6. And I already made a mistake, I know. You don't have to yell at home or here. You don't have to be like, you're making a mistake. This is open, so we should not be having that equal sign. It makes a big difference, okay? It's the little things. Okay, there. And then it's going to be less than, also not included, +4. Okay. Open dots. Okay. Because of the open dots, it's not included. Here, again, X is there. You know that it's going to be like this. It's going to have an equal sign. And you can be guaranteed that we're going to go, right, like this because X is between two numbers. So it's going to be greater than this, but less than that. Okay. So we're going to go from 0 to 3. Sorry. Here we have both solid. So it's going to be from 7 to, I'm guessing 10. It's hard to tell. Here I'm also contained, so but it's not equal on this side. It is on this side. So it'd be 6, and this would be -1. And here we have it's also contained, no equal sign on this side, but there's an equal sign on this side, which is -7, and this is 1. And then we have no equal sign on this side, but there's an equal sign on this one. So we are going from -2 to +2. So there you have it. That's a review of inequalities, which is huge for what we're about to do. Yeah. And you will be able to tell in a bit that there's tons and tons of domain and range stuff. Okay. So I'm gonna get to this page. Try to have it all on there, at least the top. Okay. So remember, shading, when you're thinking of domain, I want you to think of the x values. Range, I want you to think of the y values. And you're going to think horizontally when it's domain, and you're going to think vertically if it's the range. Okay. And it says shade in the domain of these graphs. The domain of the relation, right? So I want you to highlight or underline this. The domain of the relation includes all the x values the graph crosses. Okay. So I want you to do this. We're not going to do the shading here, but right now on this graph, we're just focused on the x values, right? So I know that this line goes off like this, like we're so used to our number line going this way. We're going to project that along the x-axis. Okay, so you're going to go from here to where the graph stops, which is right here. Okay, but we're going to make sure we put an open dot at the end. Okay, so I will project graph on. We're not going to do this later on. This is just for you to understand. Project the graph onto the x-axis. So it's almost like if it were to make if you had a light up here, this is the shadow it would make on the ground. Okay. So the domain here, this is how we do this, folks. And I know you're used to this notation. The domain, if you watch the videos, that is, it's contained. So we're going from 1 to not including 4. Okay, so if we just imagine that the highlighted line is your number line, and so you're going from 1 to 4, so it's contained. It's including 1, but it's not including 4. Okay, so we're going to do the same thing here. So we're starting here along the x-axis, and we're just going to travel along the x-axis for as long as there is a graph. Boom, you stop there. And this is open here because that is open. Okay. This one is closed because that is closed. Okay. So my domain, so we're translating from just inequalities to now talking about the domain of this relation. Okay. Do you hear me? I hope you're not falling asleep. Okay. So this would be -5 included. X is the variable in question because we're talking about the domain. We're going to do the range right under this. And this is not included, so we're going to go like this. And this is 8, 9, 10, right? So we're at 10 squiggly brackets. If you watch my videos, that's what we did with domain and range. However, it was only individual points up until now, right? I did points, 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 points. Now it's a line. So there's all the points possible that you can possibly think of are between -5 and 10, right? So that's why we use this notation and no longer individual points. Okay, the domain here, I will do the highlighting just for this page. So I start here and I highlight along the x-axis until I stop there. So as long as I can see the graph above me or below me, I keep highlighting, okay? So this is open and this is solid because I just matched the ends, right? It's contained. So we're gonna go, this is a -1, not including. X is less than 10, included. Boom. Let's do another one here. Highlight, highlight, highlight. I see a graph, and then I stop seeing it at that point. This is solid, this is solid. Okay? Domain here is 1, 2, 3, 4, 5, 6. -6. Always lowest first. That's very important. Lowest first, highest second. Okay? And then both of them are included. And so I have, right, equals on both sides. So this is a bit of a catchy, cheesy. This would be a closed domain. This would be a clopen. That's pretty funny, isn't it? Because it's closed and open, right? Like it's and there's also a clopen, right? So this is a closed, right? So the both are included. Okay. There we go. Let's do the range now. What is the range? So here you have to be careful. Okay. We're gonna now project because it's the range. Let's highlight what the range is, and that'll be it. I will just go through this. That'll be it for today. The range of relation includes all values for which the y values the graph crosses. Should I use? I'm going to use the same color if you don't mind. But now we're going to project along the y-axis. So we start here and we go until we see no more. Okay. So this is solid. And this is open. Sorry, I went a little bit past. I shouldn't have done that. We're kind of here. So this is a little tricky here, trickier, because we're now looking at a vertical line. So the range, you always start from the bottom and then go up, okay? 0 is included, and we use y, notice. It's less than, I don't know, this looks like it's going to be 1 2/3. Yeah. We'll call it 5/3. Less than, not included, 5/3. Oh, I don't know why I did that. Like that. So, can I just give you a little hint? If you want to do this on your paper, turn your y-axis like this if that helps you, right? Because then it's lowest to highest, right? If it, I don't know, I'm just giving you some hints and some tricks here, tricks of the trade. Okay, what about this one here? We start with the lowest here, so we're at -3, and then we're going to highlight along the y-axis for as long as we see the graph, and it stops right here. Okay, so this is open here because of that, and this is solid. I did not extend past where I see the graph. Okay, so the range here is, I'm going to start with the bottom always, -3 greater than or equal to 9, not included, right? I'm not including the top here, which is also 3. 1, 2, 3. Yeah. We're almost done, guys. So it's different, right? Like I'm projecting. It's almost like I'm starting at the lowest point. I'm like, yeah, I can see the graph to my left, to my left, to my left, to my left. All of a sudden, boom, right? I see them. I see things also to my right, but it's only as far as you can see some graph. Okay. If I had gone past it, there's no more graph up here or down here, right? So that it ends there. So that's your range. Okay. One more here. We start at -4 and we travel all the way up to +4. This is not included. This is included. Range is going to be from -4, not including, and now using y, less than or equal to +4. 3 minutes, 3 minutes. Here, I'm always starting at the bottom. So this one is important. This one can throw you off. I'm going to zoom in. You notice that this point is a little higher than the lowest point here, right? You got to include everything. So we're going to go from here all the way to the top here, which is right there. So this is a solid because this is solid here. Even though there isn't one big dot here, it is included. And then here we have a dot here, and all along this is all solid anyway, so it's solid, solid. Okay, so range would be from -2 to +2. So notice that if you look carefully, we did the domain and range for every single graph. It's the exact same one on top and bottom. Okay, so you're gonna have to down the road be able to look at a graph and find both the domain and range. Hold on, before we go, I need to send you off with some practice on this. Okay, it's really important because it's confusing if you don't practice. So let's keep flipping through these pages. And I'm going to ask you to try this page right here. Don't worry about the, oh, it's asking for the domain and range and whether or not it is a function. So this is your homework. Let me just keep flipping through it. I want you to do this one and the next one. This one as well. Okay, everybody see it at home? So this one and this one. If there's any talk about interval notation, don't worry about it just yet. I'll do that on Monday.